welcome to Supercompute. Hope everybody's having a good week so far. Starting to feel a little bit nostalgic here as we look at, for those of you that have been here for years and years, a little bit of retrospect as we start bringing water back into these big giant computers, reminiscent of the mainframe days. But I think things are slightly different today, arguably, because the stakes are a lot higher. Densities are growing exponentially. Hardware costs are astronomical. And the challenges that we're trying to solve are much bigger. It's the size of those particular challenges that drove me and my team to develop a brand new technology, a brand new data center platform itself. Today I'd like to talk a little bit about that topic, but in particular, let's talk about sustainability and tie everything back to it. This topic's not new to anyone, but I think I'd like to explore in today's session our ability to kind of chase both performance from a sustainability perspective, as well as not just looking at power and water anymore, but on the building, the investment we're making in those pieces of infrastructure, the massive investment we're doing in hardware itself. And we'll talk about all three of those things as we kind of go through our presentation today. Just a little bit of background, I'm Chris Orlando. I am the CEO of Scale Matrix Data Centers. We've got 5 data centers here in the United States. Me and my team have been building co-location and enterprise facilities over the last 25 years. We've done a lot of builds. About 10 years ago, after a sale process, we knew that physical security, power, and efficiency were going to be 3 of the things that we thought would differentiate data centers as we progress down this path. We know those would be challenges for us. So that design, over time, went away from raised floors and hot row cold rows into what we believed was something that is no longer kind of one size fits all. Building one data center at one density level didn't work. We were very early to that particular game. We built an entire facility with enclosed racks that support 35 kilowatts of power per rack. This was back in 2011. Everyone told us we were crazy, that no one needed it, but it looked neat. And so we said, we're just gonna keep being crazy and doing it. And so we persevered. It was a tough road from that whole decade of time when densities kind of just bounced along. We had some struggles, but we made it. A bunch of customers said, we like the technology. Again, we don't need it just yet. As COVID came, right, we started to see densities go up just a little bit. And as COVID ended, obviously the AI explosion happened and things really started to go big for us. In January of this year, after demand had really started to increase, large investment company, 3 different firms, put a sizable investment into our company that allows us to start scaling and getting ahead of some of this AI demand. And today I want to talk about how some industry insight that we've recently seen about mega trends in the data center space, tying back to overall sustainability, and how we have to look at building data centers in the future to try to get ahead of it so we don't waste money, time, and effort as the challenges that we're all facing change every single year. So I'll give you just a little bit of background on the product and then we'll jump into some of the sustainability challenges. Yesterday here at the show, we announced the V4 of our DDC cabinet. The cabinet itself is a fully enclosed rack that sits on any data center floor, connects to a power and a water connection, and it provides up to now 100 kilowatts of pure air-cooled load at the rack level. We are using liquid as a heat exchanger at the top of the cabinet itself, but that liquid and that heat exchange happens outside the IT environment, so there's no risk of liquid impacting any of the infrastructure that happens inside the cabinet itself. And for many of you that are mathematicians and scientists and understand fluid dynamics, it's very difficult to cool 100 kW with just air in a rack, but it is something that is functional, it's happening, you can see it in our data centers today. And it's done through some really, really unique combinations of high velocity fans, centrifugal air motion, and some very, very specialized coils for heat exchange that we've got. Those cabinets are on display in our booth. We'd love to show it to you guys while you're here at the show. In addition, we also announced yesterday that the cabinets, because they are 100% air cooled, also now have the ability to integrate a variety of different liquid to the chip platforms. So when you combine our 100 kilowatts of air with 300 to 400 kilowatts of liquid heat abatement, these are some of the highest density cooling cabinets in the world. We're partnered with NVIDIA on their roadmap teams. We've seen kind of where densities are going to go in the next couple of years. And we want to talk about today about how we plan for the future so that we don't invest in data center infrastructure today that may be obsolete here 3 or 4 years down the road. Some of the key features of the cabinets, just as a highlight so that you know where we're talking about when we talk about some of the advantages that we see from a sustainability perspective. The cabinets are NEMA 3R sealed, so from the exterior, there's nothing that gets into the cabinet itself. As we deploy more water in the data center, whether it's for liquid to the chip or just generalized cooling. There is more water traversing data centers today, and that creates risk for customers. So the cabinets are NEMA 3R sealed. That benefit also extends into the fact that the cabinets can literally be placed just about anywhere. They are not rated for outdoor capabilities, but they are rated for being in warehouses and distribution centers and automobile manufacturing facilities, anywhere where you need to take AI or HPC platforms. These are basically a data center in a box. All you do is connect them to water at the top and provide them a power source, and everything else from air handling, filtration, humidity management, volatile compound sensors, all of the thermal management integration, everything happens inside the box. They're inexpensive comparatively, even though they have a lot of capabilities. They're similar in price point to what you'd cost for a real door, but they are more of a full data center solution out of the box. And at 100 kilowatts of air cooling, they provide a very significant ramp for customers who may not know exactly where their density requirements are going to lie 6 months from now, 2 years from now, 5 years from now. The box is kind of a one-size-fits-all solution. We do offer it in a couple of different widths. As we're starting to see massive networking requirements coming out of HPC applications, the cabinets now have specialized areas on both sides of the IT rack itself, so that there's room for exceptional amounts of network cabling and fiber. And we've designed it in a way so that we make sure the bend radius of those large network deployments still stick within the functional specs of those cabling pieces themselves. We also have a variety of different heights. You'll see some of NVIDIA's designs here later, where we've got 23 and 24 foot high ceiling heights. We are going to have to start looking up as we design data centers. It's simply a fact. We're going to need more headspace for water distribution, power distribution, network distribution. So the cabinets come in a variety of heights as well that can be chosen based on the application or the site that you're building into. So the global trends that I talked about when we started, this is a report that came out from Gartner in June. And it's fascinating to me that if you read through these particular pieces, they kind of mirror our product development track at DDC, which is pretty exciting. It means our product engineers and folks were pretty on the mark when they did their last rev for us. I think none of these things are massive surprises, but when you add them all up together, they really talk to the fact that we have to rethink a little bit of how we're doing data centers moving forward. Modularity in design, I think that's key. We don't know what's happening at every single rack, row, or level in the data center anymore, so being able to be modular in the way we deploy infrastructure, obviously a mega trend from the Gartner perspective. Reducing things down to units of compute, units of data center capacity, so that you can add and plan with a little bit more strategy as you're building things out, that's key. I think everyone in this room is familiar with the ultra-high density challenges that are happening, whether it's happening in your applications today or you're planning for it in the future. The numbers that are being thrown around, about 300, 500, 600 kilowatts in a rack, may not be impacting you today, but there are real requirements that will come someday. And it's happening faster than it used to. So if we're planning for a 10, 20-year horizon on a data center investment, we need to make sure the building blocks that we place in place to support those things are really scalable. There is a conversation between many of the GPU manufacturers about how much air cooling will be required in final format for some of these deployments. And there's numbers thrown around between 70% liquid cooled to 30% air, 80-20, 90-10. If we're providing 100 kilowatts of air cooling and you can max 90% more of that with liquid, you're starting to get up above a 500 kilowatt rack. That's a half a megawatt in a single 45U. So may not be there today, but we certainly want to make investments in tools that do a great job cost effectively at our current requirements level, but without having to make any changes to the data center, scale and can add capacity on demand without being disruptive to the workload and without being disruptive to the data center or your operation. So that's one of the targets and things that we're working on. Intelligent automation, I think this is paramount. When we were managing data centers at the facility level, it was very hard to discern specific information about what's happening at one platform level, one rack level, even sometimes one row level. When you flip the data center upside down and start building at these enclosed rack levels, the telemetry inside the rack provides a plethora of data that allows us to make better intelligent decisions about automate and use intelligence to make decisions about how we're running data centers. And what's great, our product timeline, it's not just the cabinet technology that we sell, but it's also an overlay of some very powerful software that helps concatenate all that data into a single screen so we can be more efficient, be more intelligent, and run our applications at their maximum peak performance around the clock. And then power efficiency, harkening back to our thoughts about sustainability, we've all known that's something we need to do. Today, putting a very high density application in a traditionally built data center can sometimes wreak havoc on the cooling systems and play games with your monitoring solutions because you don't really know how much heat is coming, where it's coming from, and why. And so having to rev up a cooling system to abate one or two applications that are running hotter than the rest of them is wasteful, right? We're not being as efficient as we can. So by concatenating everything down into a single rack and putting a lot of telemetry in front of it, we're able to say that rack is the offending rack that has these issues, and we want to make sure we route more cooling to that rack while removing some cooling from other racks that don't have the necessity going on at that time. We know that AI workloads and HPC workloads ramp up and down, and if we can intelligently predict that and see how that's happening and only deploy the resource needed in the data center based on real-time load dynamics, we can be much more efficient from a data center perspective. And that's something that we're doing in real time today. And it ties back to kind of these mega trends that Gartner's been talking about this summer. So on the sustainability front, right, I think everyone is aware of kind of liquid and power requirements. Let's always try to save power and cooling costs. They're a big driver for costs in these overall platforms. But I think we also start to need to think about sustainability from a design perspective and how we actually build the data center. Not just so that we get what we need out of it, but so that investment lasts longer, 20, 30 years. And it's difficult with the trajectory of change that we're on now to predict those things. So we want to make sure that if there is a solution that costs the same to build as a raised floor with hot and cold aisle encapsulation, but does 10 times more cooling at the rack level today, that seems like a better building block to start from so that we don't have to reinvest in large changes 2 to 3 to 5 years down the road when the application refreshes happen, right? And from a hardware operations perspective, this one may be a little more nascent, not as obvious, but if you can control the environment around the server itself to almost a surgical degree and keep the temperatures in those server inlets the same year after year, and keep particulate and dirt and all those things from data center operations out of those servers for years, you'll actually see the lifetime of those servers extend. So we're getting more investment out of the dollars we put into those server hardware pieces. And also, if you can surgically control the temperature and the amount of CFM being supplied to the front side of that server can run in peak output performance more time than not, and so you get better overall performance. And I think a mix of all three of those things, energy, facility design, and investment in both hardware and infrastructure, if we act more sustainably across the board in all those things, we can see an exponential improvement in the way we're operating data centers. So we'll take that first one in stride here. Tenet number one, obviously power and liquid cooling. Things that we focus on when we're talking to customers about how to solve for these things. Obviously liquid is a very efficient way of exchanging heat. So in our cabinet design, while we're using air as the medium inside the IT environment of that enclosed cabinet to cool the infrastructure, above it is a liquid air heat exchanger, right? Very efficient way of moving the heat. The exchange happens very close to the actual heat production, and everything stays within that cabinet environment. Again, it's a NEMA 3 sealed cabinet, so no air ever leaves the environment. So that means it doesn't bleed out into your data center itself. The noise from the GPUs and all the other things are kept inside the cabinet, and you have a very effective and efficient exchange of heat at the cabinet level. We also are obviously talking to more and more customers who choose these cabinets to go into their data center floors about their water supply loop and how it's being designed. A closed loop design, previously may not have been as cost effective as a evaporative system, but today if you can save millions and millions of gallons of water by using a closed loop system and run it efficiently, that is something from a design consideration that we all should be looking at. We know there's areas and regions of the world today that are limited in data center capacity because they don't have enough water to produce. That type of evaporative cooling, closed loop, is a design consideration we should be thinking about as we look towards more efficiency. On the power side, I think many data centers today have preemptively gone and got variable speed fans and motors and pumps and controllers. And those are all very valuable things from a power savings perspective. But if you take those things, as you see on the bottom of the screen there, that's each particular cabinet in one of our data centers has its own water metrics tracking system about how many gallons or liters per minute of water is being required at the cabinet level to adjust, and it adjusts in real time to cool whatever the dynamic workload is inside that cabinet. We have customers today that will run 5 kW idle, 75 kW at peak, right? Traditionally built data centers have a tough time managing that adjustment. This system not only reads thermal output from the servers themselves so we can sense if there's a warm-up, but we're actually monitoring the power utilization at the rack level so that we can get ahead of those warm-ups before they happen. If you see a large increase in kW demand, we say, oh, there's a new process that's running, let's pre-cool a little bit into that rack. And we're doing so in such a way that it truly is matching cooling and energy usage based on the exact workload happening in the cabinet in real time. And so if you do that at the rack level, there's huge savings. If you multiply that then by the data center level savings, we're producing PUEs and WUEs they're industry leading right now, all just by having a little bit more data and a closer amount of control over what we're actually cooling and how efficiently we're cooling it and trying to get ahead of these thermal outputs. So I think we're doing a great job on sustainability tenet 1 from a power and efficiency perspective. The things that we think millions of gallons of water saved and industry-leading PUE and WE is the output that we're trying to deliver for customers today. So that's kind of tenet number 1. Tenet number 2, is data center design. I think there's like a million people talking about it, and we're all considering like what's next and how to do it. Modularity, as we heard in the Gartner output, is something that we need to think about. This whole build it and they will come thing. There's lots of customers that will just come buy everything you've got these days. But we want to build it intelligently. We want to build it so we don't have to go back in and retrofit it later to deal with what other densities are out there. And we're seeing this huge spike in density. Being prepared for it and making intelligent decisions about the base platform we're building into our data centers hopefully will help. Scalability from an efficiency and a density perspective is obviously very key. And then having the ability to take individual racks or entire rows and after you reach the 100 kilowatt threshold, right, be able to add liquid to a specific rack because we have all the manifold inlets and space built in there for water distribution in the cabinet already. It allows you as the end user to say, hey, look, we've got 100 kilowatts. That's going to last us for X period of time. At this point, we fear we're going to be ready. So we've universally designed the entrances and exits in and out of these cabinets to be able to allow you to choose any different liquid to chip or chassis provider and integrate it right in at the time of your choosing when it makes sense. So you don't have to make paradigm shifts in your data center today just because you need something. This allows you to do it rack by rack and just provided as much support for those systems as you can so you can truly reach these 300, 400, 500, 600 kilowatt racks when the time is right, when it's right for you. Being able to forecast those densities is difficult, so we just try to make it easy for customers to adjust to them as the workloads change. I think this is just a kind of something that we're talking to every customer about today is, whether you're seeing densities in your data centers of 50, 60, 80 kilowatts, we are because customers are attracted to our particular brand because they know this technology exists in our facilities. But I think, we're on a path to being able to produce 100 kilowatts in a cabinet very simply, and a lot of applications are already targeting amounts above that. So a combination of efficient air and extremely efficient water is the way we're going to get up past those things. And we talked earlier about the 90-10 split, the 80-20. We don't know where that's going to land, but we know that with 100 kilowatts of air cooling, it sets you up into a really good spot to be able to support whatever that split is going to be. And if you can build data center space using building blocks like these as cost effectively for 100 kilowatts as we are for 15 kilowatts a rack, why you might as well future-proof as much as you can and go with a solution that scales and moves into water seamlessly without interruption. Tenet number 3, hardware operations. This is a little harder sometimes to grasp, not as easy to put your pinpoints on the exact numbers that are returned, but the numbers can be staggering if we get these pieces right. Things that we were concerned about from a hardware operations is responsive thermal management. I think we all know that in the HPC world, workloads go up and down. As I mentioned, we have customers that idle at 5 and hit 70 during their peak, and it happens all day long up and down. Many traditionally built data centers do not deal with that well. Hardware doesn't like to have to wait for hot and cold aisles to catch up and those type of things. So in this environment, you literally, any instantly affects the amount of water that's traversing individual cabinet coils and the exact fan speeds. The fans in these systems produce up to 10,000 CFM at the supply side, and a redundant fan in the rear brings 10,000 CFM off the backside, eliminating hot spots in the back of the cabinet and producing a tremendous amount of precision-controlled air so you can keep the operating environment inside these cabinets ideal so your server hardware works as good as it possibly can. It doesn't have all that contraction and expansion from different hot pockets building up when you burst in and out of traditional workloads. Something definitely we've been keeping our eye on. Because I mentioned the cabinets are NEMA 3 sealed, there's no particulate or dust that gets into the cabinets themselves. And so this is helping extend the hardware for a number of things. And less dirt, less temperature variation, hardware lasts a little bit longer, which is a really great thing. And finally, and this is one that we're starting to think about, the cost of the AI platforms, the HPC platforms we're deploying in these environments is beginning to be astronomical. Single data center builds with over $1 billion in GPUs in there. If the sprinkler system goes off, or if a pipe leaks when you're distributing water to a different part of the data center, those things can be catastrophic to the platforms you're building. If it happens in these environments, all of your hardware is 100% safe. They're NEMA 3 rated, RAIN rated cabinets that go directly in your data center and protect them against all of those type of things. Tying back to the Gartner report, and I was very pleased, as I said, that this follows our roadmap. Dynamic management in the data center is something we need to do more of in order to meet and achieve sustainability goals and just to operate better data centers overall. Increasing in efficiency, you can do it by using less power and less water, but if you use a system with lots of intelligent data being fed back in, we can make even better decisions and reduce our costs in the data center even further, saving more resources and being more sustainable. Designing for non-evaporative systems, it's a choice that you have to make depending on where you're at, but it certainly can save a lot of water if that is one of our tenets. And then monitoring and visibility into these key platforms is something that we just have to do moving forward. Seeing things at the facility or row level will not give us the depth of information we need to manage these platforms great. And if you do invest in the DDC platform as a solution for any of these things, it comes with a very, very robust software overlay that allows you to see facility, row, cabinet, all the way down to the most minute detail and make really good decisions about what's happening at the rack level. If you specifically tune one rack and these airflow and temperature set points for your application and you like it, copy and paste that to any rack in the data center that has a similar hardware profile, and you're off and running with no human intervention required. Final point I'll leave you with, as I'm getting the note here that we're almost out of time. I obviously love the product, and we're getting a lot of interest from very, very big players in the market. But this was a local data center operator, Tier Point, 40 data centers around the country. They just deployed a 15 megawatt, very large GPU platform for a customer. The project start to finish was less than 1 year. Obviously, using these cabinets to deploy brings data center resources online very quickly, since you don't have to do all the fit out of the actual data center floor like you did previously. They had 300 cabinets for the 15 megawatts, so every cabinet running above 50 kilowatts. Very, very small footprint, and it's working fantastically. They compared our solution with containment, rear door, and other solutions. They found it to be the lowest cost solution to build day one. So less cost to build, and then obviously from all the intelligence that we provide, less costly to operate because we're using less water and less power. This is an actual project going on right now. We're in booth 1413 here at the show. We have the cabinets on display. The folks from Tier Point are actually in our booth talking about the project they did. And our entire engineering teams and firms are here. We would love to spend time investigating how these products can help you guys plan for the future a little better, build more efficient data centers, and achieve all across the board on those 3 sustainability targets that we talked about today. I appreciate it.